Okay, so we're going to pick up where we left off in the previous video. We're working with the average value of a function, and we want to find the average temperature to the nearest degree Fahrenheit between t equals 6 and t equals 14. Now when you answer a calculator-based AP calculus question, you need to write down the formula that you're using and not just your answer. You need to write down an expression, a calculus expression, as well as the answer and not just the answer. And so for part B, we're looking for 1 over b minus a, which is 1 over 14 minus 6, or 1 over 8, times the integral from 6 to 14 of f of t dt. You don't have to write the whole expression out if f of t is clearly defined in the problem or somewhere on your paper. So to evaluate this, we're going to go to the calculator. It may be possible to do this without a calculator, but we're certainly going to use our calculator here. On a calculator-based question, even though you may be able to do things by hand, if you're able to use the calculator, use it. Save the time that you have to do the problem. Okay, so we have the graph here, and we want to take the integral of this function from 6 to 14 and then divide that by 8. So we do second calc, option 7, the integral function. Lower limit is 6, upper limit is 14, and we get a value of 697.29578. Now the value of the integral there is stored in the memory, and if I just hit divide, that value is in the answer. And I want to divide that by 8, and that gives me 87.162. Now normally we're going to round to 3 decimal places, but in this case it asked to the nearest degree, so here it would be 87 degrees Fahrenheit. Alright, so that's all you need to write for the problem. Don't just write the answer. You have to write the expression, the calculus expression that gives you the answer as well. Okay, we're going to put the calculator away and go on to part C. I'm going to scroll down a bit for that. Now part C says that an air conditioner cools the house whenever the outside temperature was at or above 78 degrees Fahrenheit. For what values of T was the air conditioner cooling the house? So I draw this red dash line in there for 78, roughly, and what I'm looking for is where is the temperature at or above 78? And it would be at these 2 points here, anywhere in between those 2 points. So I'm going to call those points A and B. And to find those points, what I'm going to do is use the calculator again. But this time I'm going to go in and add a graph of y equals 78. So I go to y equals, move down to the next to y2, 78, enter. And when I go to graph that, you're going to see the new line in there. Now I can easily get rid of what's on the screen by doing second, draw, clear draw, and then it's going to redraw my graphs without the integration filled in there, or the area under the curve shaded. So what I'm looking for here is the intersection. So I do second, calc, intersect, and I'm going to move a little bit closer to the first one, enter, second curve, enter, guess, there, and I get x equals 5.2308. And what I'm going to do is store this in the variable a. So I'm going to go back out to the main screen and say x, because that's where the value is stored. You just saw x equals. It's storing it in a system value variable called x. Store into alpha a, and it stores that value for me. So I don't have to worry about all of those decimal places. Now I am going to write them down on my paper because in the future, instead of referring to that value, I'm just going to refer to A. And as long as it's labeled clearly on the test, then it's fine. And I'll do the same thing with B. I go to the graph. I'm going to choose intersect. And I move over closer to the second intersection. That would be my first curve, second curve, guess. And it says it for me there. And I'm going to write it down on the paper, 18.769, rounded to 3 decimal places. And I'm ready to write down my answer, so I'm going to close down the calculator here and say that my answer for C, my answer will be for T is greater than 5.231 but less than 18.769. And I can also say for T greater than A less than B.